Chapter 5, Section 1, Simple Interest and Discount. Now, those are the two big topics we're going to have, so we'll dive into simple interest. So let's just look at an example to begin with. Example 1. To buy furniture for a new apartment, Candace borrowed $5,000 at 8% simple interest for 11 months. How much interest did she pay? All right, so if we look back at this equation, this fact right here, fact 1, simple interest. The simple interest I, okay, so I is the interest, on P dollars at a rate of interest R per year for T years is I equals PRT. So P times R times T. Okay, so in this case, we're asked for the interest. How much interest will she pay? So we need to take our principal, the P dollars, times our rate per year. Okay, it's 8% per year, so there's our rate. And simple interest for 11 months. Now, because this is months, we are going to have to convert that to years. Okay, so let's see. I equals P, 5,000, times rate, 0.08. You have to convert that to a decimal. Times time, which is going to be 11 out of 12, because that'd be 12 months in a year. So our interest is, multiply those three out, 366. And if we round this to the nearest hundredths place, 67. So the interest is $366.67. That's all there is to it so far. All right, next we have on January 8th, 2013, Bank of America issued 10-year bonds at an annual simple interest rate of 3.3% with interest paid twice a year. John buys a $10,000 bond. Okay, so let's see here. We're eventually, I think, going to need this for the 10-year bonds. We have $10,000. That's going to be our principal, deposited amount. Here we have our rate. And then this right here, it says it's paid twice a year. Okay, so how much interest will he earn every 6 months? Okay, well, first off, so interest equals principal. So he has $10,000, a rate of 0.033 as a decimal, times time. Well, this is 6 months out of 12 months. So the interest he gets just in that 6-month period is, oh, I thought I had that one worked out, $3,300. Okay. Yeah. Let me double check. That doesn't seem right. $165. Oh, I think I may have gotten ahead of myself. All right. So $165. And hopefully you're working these on your own anyway so that you can check me. So my interest is $165 every 6 months. How much interest will he earn over the 10-year life of the bond? There are actually two ways to work this part out. Okay, you could either say, well, $10,000 at 0.033 for 10 years, and since it's years, you don't have to do anything else with it, in which case you get $3,300. Okay, or you could say, well, he's getting $165 how many times? It's twice a year for 10 years, so that would be 20 times. And so we get $3,300. So because that interest does not compound, it doesn't build over time, it's just the same occurrence happening over and over again, we can just do it that way. So $3,300 in interest over that 10 years. All right, example 3. All right, we have a deposit of P dollars at an interest rate of R for T years will produce interest of I equals PRT. The future value of A can be found, and this is actually worded poorly. The future value A, so A is the future value, can be found using the equation A equals P plus I. Okay, the principal plus the interest is how much the total amount is. And it can be found using this equation here, A equals P times 1 plus RT. Now, you can actually use this section here, these two formulas right here, to derive this right here. Okay, because what this comes down to is A equals principal plus principal times rate times time, the interest part of that. Factor the P out, and you get P times 1 plus RT. Okay, so you can really use either one of these formulas. This is just the one we prefer usually. Okay, so find the maturity value and the amount of simple interest earned. $12,000 at 5.3% for 11 months. So find the maturity value. Now we have a principal, a rate, and a time. So first, we'll go into this formula. A equals P times 1 plus 0.053 times 11 out of 12. Okay, so that will give us the maturity value, which will be $12,583 and no change. So there's the future value. So in 11 months, that's how much the amount of $12,000 will actually be worth. So the interest then, okay, the amount of simple interest earned is this amount minus the original $12,000. So $583. So that's $12,583 minus $12,000 to get our interest. All right. That's all there is there. Okay, example 4. Find the maturity value of a loan of $11,280 for 85 days at 7% interest. Okay, there's our rate. There's our time out of 365. We're going to assume 365 days in a year. And there is our principal. So find the maturity value. Now, just like I said before, there are two ways you could do this. You could first find the interest and then add it to the principal. Or you could use, just add the two together, you'll get it. Or you can use the formula A equals P times 1 plus RT. 85 out of 365. Okay. So in either case, you should get, let's see, there we go, $11,463.88 if we round that. Okay, so that is the maturity value. Now, this didn't ask us for the interest, but if we did that, we would take this amount right here, $11,463.88, subtract $11,280 from it, that'd be our interest. All right, example 5. If $23,500 earned simple interest of $1,057.50 in 9 months, what was the simple interest rate? All right, so 9 months is our time, okay, out of 12. This is our interest. Okay, this earned the simple interest of, okay, so this is actually our principal. So our principal, interest, time, and we want to know what is the rate. All right, so, okay, so there are two ways you could do this. One, okay, which I kind of like, is first find out what A is. That would entail you adding the interest and the principal together, which would be 24,557.50. Okay. Okay, and then we would take A equals P times 1 plus RT, 24,557.50 equals 23,500 times 1 plus 0. That we don't know what the rate is. So R times 9 out of 12, which is 3/4, and we have to solve this equation. Okay, so divide by 23,500, and if you divide by that 23 23. Should get 1.045 equals 1 plus, I'm going to write this as 3/4 R. All right, so subtracting 1 from both sides, we get 0.045 equals 3/4 R, and then dividing by 3/4, R equals 0.06, 0.06, which is 6%. That's one way to do it. Now, honestly, that's the first thing I think of because we've just been dealing with that formula. However, there is actually a little bit simpler way to do this. Okay, so we have P, I, T, and we want R. Well, interest. Oh, I did that right. 7.50. So, interest equals principal times rate times time. So the principal is 23,000. I don't like that. 23,500. Okay, times rate times 9 out of 12. Okay, so we divide by 23,500. Okay, which will give us 0.045 equals 3/4 R divided by the 3/4 of the 9/12, and you get that R equals 0.06 or 6%. In either way, you get the same answer. Okay, whichever one occurs to you the first, that's what I would do. All right. Next problems we have. All right, find the present value of $32,000 in 4 months at 9% interest. Okay, now the thing to notice here is present value. I haven't seen that word yet. But what that means is how much it's worth now if it's going to be $32,000 in 4 months. Okay, so this is the maturity or the future value. Okay, so there's A, time, 4 out of 12. Sure had a lot of months in this. And then 9%, that is our R. And we actually want to find P. Now, there is a rearranged version of the formula we had previously that we could use. Okay, so A equals P times 1 plus RT. If you divide by 1 plus RT on both sides, you get this equation. Okay, P equals A divided by 1 plus RT. That's kind of useful right now. Okay, this would be the present value formula, but it's useful when you want to find that. All right, so P equals 32,000, 1 plus rate 0.09. Yes, that's a 9. 4/12, which is 1/3. So our present value is 31,067.96. All right. Once we round that to the nearest hundredth place. Okay, so what this means is if you deposited this much into an account for 4 months, getting 9% interest annually, you would get 32,000, or at least something close. Actually, it would be a little bit more than that, than 32,000, because we rounded here. Okay, but that's what the present value is. How much you could invest now to get a certain amount later. Which is actually what example 7 is about. Okay, Jarrell Davis is owed $19,500 by Christine O'Brien. The money will be paid in 11 months. Okay, we have a time out of 12 with no interest. If the current interest rate is 10%, how much should Davis be willing to accept today in settlement? So the key thing here is he's accepting it today, so we want to know his present value, okay, the principal. Now we've got a rate right here, so obviously it's the rate. But when it's the current interest rate, it means that's the interest rate he could get if he invested that money. Okay, so we've got time, principal, rate. That's everything we need. Okay, so principal, I'm going to use this version of that formula here. Principal equals, it needs to be worth $19,500. Okay, Okay, 1 plus 10% interest rate, 0.1, times 11 out of 12. Okay, so this actually is our future value. Okay, so if we do calculate that, we should get that our principal, or our present value, is $17,862 and 60 cents if we round that. And again, say that again. If I took this amount right here and I put that into my interest formula and then added that all together, I should get something like 19,500. In fact, let me do that real quick. Okay, so I actually get $19,500 and 0.005. So I get half of a penny. So I'm really close, but not quite. A little bit over. All right, last problem, I believe, is on T-bills. Okay, so T-bills are called Treasury bills. While this is the most common simple discount loan. Okay, now this is a little bit reverse what we've been thinking. This whole time we've been thinking, okay, we put money in, we get interest, we add it together, that's how much we have now. Treasury bills work a little backwards. Okay, they are sold at a discount of their face value. The discount's the interest deducted in advance from the face value. The Treasury receives the face value less the discount, but pays back the full price. So what that means is, say they are needing money in the Treasury, okay, which happens pretty often. Okay, say they're issuing Treasury bills of $100, say $100. Okay, that means you're going to pay a discounted price on that. You're going to pay $99, just for instance. You're going to pay a little bit less, but in the end, once it matures, this is actually how, by the way, how these things work. That means when it matures, you will actually get $100, even though you only paid $99. So the Treasury receives the face value less the discount, but they pay you back the full price. Okay? So let's look at this example. We're not going to spend too much time talking about this, but this is important. All right, an investor bought a 6-month, $8,000 Treasury bill. Okay, that is our, I'm going to guess, kind of our principal. 6 months, that's a time frame. Bought this $8,000 Treasury bill on February 28th, 2013 that sold at a discount rate of 0.135%. That's a really awful interest rate. What's the amount of the discount? And then what's the price of the T-bill? So the way you find the discount, it's actually a simple interest rate, an annual interest rate that we use, but it's simple interest. So we're going to take our discount, and I'll write this out. Discount equals our principal times our rate, 0.00135, I believe. Yes. Okay, times time. Well, it's 6 months. So 6 out of 12, which is actually a half. And if we multiply that out, we should get $5.40. So that's the discount. That's how much they are going to knock off the price when you buy it. Okay, now our face value, or the amount that the price of the T-bill, what they're going to charge you, is going to be the face value minus the discount. So originally it was an $8,000 bill minus $5.40 should give us $7,994.60. Let me make sure of that. Yes. Okay. So how much you will actually pay for it? You'll give them $7,994.60, and they, in 6 months, will give you $8,000. Now, the longer term you put on that, the more you're actually going to make out of it. All right, so that brings us to the end of this section, and I believe we have work to do.